Before we look at the rest of the number systems, we want to look at two things. These are fractions and decimals. Let's first look at fractions. The types of fractions that we get are as follows. Firstly, we have proper fractions. This is where the numerator is less than the denominator. For example, 2/3 or 2/3. Then we also get improper fractions. This is where the numerator is greater than the denominator. For example, 7/5. Then a third type of fraction that we get are the mixed fractions. For example, 4 and 2/3. Now, any mixed fraction can be written as an improper fraction as follows. Let's take 4 and 2/3 as an example. We multiply 4 by 3 and we add 2 to the answer. And this is put all over 3. So 3 times 4 plus 2 all over 3 equals 14/3. Let's look at the types of decimal numbers that we get. Firstly, we get non-terminating decimals. Here the digits after the decimal point or the comma continues forever. For example, the square root of 2 is 1,414,213,562, etc. So the digits after the comma or the decimal point goes on forever. Another example is 0.32, where we have dots on the 3 and the 2, and this indicates that 3 and 2 repeats itself and continues forever. Then the second type of decimal is a terminating decimal or terminating decimals. Here the digits after the decimal point do not continue forever. Examples are 125 and -30,7834. Then the third type of decimal are the recurring decimals. Here we have a pattern after the decimal. For example, 6,1, where we have a dot on the 1, and this tells us that the 1 repeats itself forever. Another example that we looked at previously is 0.32 in dot notation. Then lastly, we have non-recurring decimals, and here we have no pattern after the decimal. Examples are the square root of 2 and pi. So the digits after the comma continue forever, but there's no pattern. We now want to put together some important facts about fractions and decimals. Firstly, all terminating decimals can be written as fractions. For example, 0,1 can be written as a tenth. 7,35 can be written as 735/100. -4,159 can be written as -4,159/1000. Then secondly, all non-terminating but recurring decimals can be written as fractions. For example, 0,1 recurring can be written as a ninth. 0,018 recurring can be written as 1/55. Then thirdly, all non-terminating but non-recurring decimals cannot be written as fractions. Examples are pi, the square root of 2, the square root of 5, etc. Please try this question before you look at the answers. In question 1 here, we have to write these mixed fractions as improper fractions. Let's look at A. 4 times 2 is 8, plus 3 is 11, so 11/4. This is going to be a negative. 3 times 1 is 3, plus 2 is 5, So 5 over 3. In question 2 it says, say whether each of the following numbers are terminating or non-terminating decimals. Use a calculator where necessary. If non-terminating, say if it's recurring or non-recurring. This should be non-recurring. And in A we have 37,192. This of course is a terminating decimal, because the digits don't continue forever after the decimal. So terminating. Then the square root of 5 we can check. You should make sure that your calculator goes to or is set to at least 9 decimal places. So we have the square root of 5. And this is clearly non-terminating and non-recurring. So non-terminating and also non-recurring. Then 4 over 5, let's check. 4 divided by 5 is 0.8. So that's terminating. Then we have pi over 2. So pi divided by 2 is clearly non-terminating and non-recurring. Non-terminating, doesn't end, and also non-recurring. Then 10.3 recurring. This is 10.3333, etc. So this is non-terminating. But in this case it's recurring. Then 1 plus the square root of 5 all divided by 2. So 1 plus square root 5 divided by 2. It's non-terminating and non-recurring. Non-terminating and non-recurring. Then a ninth or 1 over 9. Let's check. 1 divided by 9. It's non-terminating but recurring. So non-terminating, but the 1 is repeated after the decimal, so it's recurring. Of course, 0.45 with dots on the 4 and the 5 means that it's 0.454545, continuing in this way forever. So it's clearly non-terminating, but in this case recurring. In the first question here, we have to state whether each of the following numbers can be written as fractions. In each case, we have to give a reason for the answer. In A, we have 9,423, and yes, this can be written as a fraction since it's a terminating decimal. In B, we have a recurring decimal, so yes, we can write it as a fraction. In C, we have a non-terminating, non-recurring decimal, so we can't write this as a fraction. So non-terminating, and non-recurring. We have to write each of the following decimals as fractions. In A, we have 0,7. We want to write the 7 in front of the decimal comma, or the decimal point. So the 7 needs to move one place forward. So it's 7 divided by 1 with a 0. In other words, 10. Here, we have to move the entire number of digits behind the comma to in front of the comma. So one has to move 1 2 places. So it's going to be 31 divided by 1 with 2 zeros. Here, the 5 has to move 1 2 3 places to be in front of the comma. So it's 5 divided by 1 with 3 zeros. In this case, we have 4 digits behind the comma. So it's going to be 9847 divided by 1 with 4 zeros. In other words, by 10,000. We have 1 digit behind the comma. So it's 62 divided by 1 with 1 zero. And of course, in C, we could simplify this 5 into itself once and into 1,200 times. Here we could simplify. 2 goes into 62 31 times and into 10 5 times. We have 1 digit behind the comma. So it's going to be 435 divided by 10. In other words, by 1 with 1 zero. Then 5 can go into 43 8 times. Carry 3. 5 into 35 7 times. 5 goes into 10 twice. In this example, we want to look at how to write recurring decimals as fractions. And in A, we have comma 1 recurring. And this, of course, is comma 1 1 1 1 1 1, etc. I have to say at the beginning that in this type of problem, we will always divide by 1 or more 9s. In this case, we have only 1 digit behind the comma recurring. So it's going to be 1 divided by 1 9 or 9. Then in B, we have 0.54 recurring. This is 0.54, 54, 54, etc. Here, we have 2 digits behind the comma recurring. So we're going to divide 54 by 2 9s. In other words, by 99. We can simplify this. 9 into 54 goes 6 times. And into 99, 11 times. Then in C, we have 0.201 recurring. And of course, it's comma 201, 201, 201. In this case, we have 3 digits behind the comma recurring. So we're going to divide 201 by 3 9s. We can now simplify this. 3 into 20 goes 6 times. Carry 2. And 3 into 21 goes 7 times. Into 999, 3 goes 333 times. In D, we have 0.05 recurring. So it's only the 5 that's recurring here. So it's 0.05, 5, 5, 5, etc. In order to use the method we've been using up to now, we need the 5 to be 1 place behind the comma. And so we can rewrite it as 0.5 recurring, but then divided by 10. We can now use the same method as before. We only have 1 digit behind the comma recurring. So it's 5 divided by 1, 9. And we still have to divide by 10. When we divide a fraction by a number, we multiply the denominator by that number. So it's 5 over 9 times 10, which is 90. We can simplify this 5 into itself once and into 90 18 times. In E, we have 0.0045 recurring. This, of course, is 0.00454545, etc. Once again, we want the digits that are recurring to be directly behind the comma. So we can rewrite it as 0.45 recurring, but now divided by 100. We have 2 digits behind the comma recurring, so it's 45 divided by 2 nines, 99, and then divided by 100 still. We can simplify this. 90 to 45 goes 5 times, and into 99 it goes 11 times. Then divided by 100 still. And we can write it as 5 over 11 times 100, which is 1100. We can simplify this further. 5 into itself once, and into 1100, 220 times. 0.37 recurring. It's only the 7 that's recurring here. So it's 0.37777, etc. Now, since only the 7 is recurring, we're going to split up this decimal. We're going to rewrite it as 0.3 plus 0.07 recurring. 0.3, of course, is 3 over 10. We want the digit here that's recurring to be directly behind the comma. So 0.7 recurring, then divided by 10. So it's 3 over 10. We now use the same method as before. This is going to be 7 over 9 divided by 10. So it's 3 over 10 plus 9 times 10 is 90. So 7 over 90. We want the denominators to be the same here. So we're going to multiply the 3 over 10, both the numerator and the denominator, by 9. So it's going to be 27 over 90 plus 7 over 90. And this is 34 over 90. And of course, we can divide both the numerator and the denominator by 2. So it's going to be 17 over 45. Let's look at the last one here. It's 7,03 recurring. So it's 7,0333, etc. We're going to split up this decimal into 7 plus 0.03 recurring. And once again, we want the 3 to be one place after the comma. So we can rewrite it as 0.3 recurring, then divided by 10. And of course, we can use the method that we've been using up to now and write this as 3 over 9 divided by 10, which is 7 plus a third divided by 10. We multiply the 3 by the 10, so it's 1 over 30. Now, 7 is 7 over 1. We want the denominators to be the same, so we multiply 7 over 1, both numerator and denominator, by 30. So it's 210 over 30 plus 1 over 30, which is 211 over 30. Let's look at your answer to this question. In A, we have 0.5 recurring, so we have one decimal, or one digit rather, behind the decimal recurring. So we divide 5 by 19. In B, we have 2 digits behind the decimal recurring. So it's 16 divided by 2 nines. Then in C, we have 3 digits recurring. So it's 304 divided by 3 nines. Then in D, we have 0.04 recurring. We're going to rewrite it as 0.4 recurring divided by 10. So here we have 1 digit recurring behind the decimal. So it's 4 divided by 19. We can first simplify this. 4 divided by 9, or 4 over 9 divided by 10, is 4 divided by 9 times 10. So 4 divided by 90. And this we can simplify. 2 goes into 4 twice, and into 90 45 times. This, of course, is the same as 0.2 plus 0.03 recurring. And 0.2 we can write immediately as 2 over 10. We want the recurring digit to be immediately behind the comma. So it's 0.3 recurring, but then divided by 10. And of course, 2 over 10 we can also rewrite as a fifth at this point. This is 3 over 9, which is a third. And then divided by 10, which is a fifth, plus 3 times 10 is 30. We want the denominators to be the same, so we're going to multiply the numerator and the denominator here by 6. So it's 6 over 30 plus 1 over 30. And of course, this is 7 over 30. Let's look at F. It's going to be comma 1, 2 recurring, but then divided by 100. This, of course, will be 12 over 99. We have 2 digits recurring here. So we divide by 2 nines. We can first simplify this. 3 into 12 4 times, and into 99 33 times. And we're going to end up with 4 over 33 times 100 is 3,300. And we can see whether 4 goes into 3,300. It does. It goes 825 times. So it's going to be 1 over 825. We're going to split up this decimal as 5 plus 0.07 recurring. Rewriting this as 0.7 recurring, but then divided by 10. This, of course, is 7 over 9. And it's 7 over 90 here. Once again, we want the denominators to be the same. This is 5 over 1. We want the denominators to be both 90. So we multiply both the numerator and the denominator here by 90. 5 times 90 is 450. So 450 over 90 plus 7 over 90. And this is 457 over 90. So in this question, we have to write each of the following roots as fractions. If not possible, we have to say why not. In A, we have the square root of 25, which we know is 5, since 5 squared gives us 25. And 5 is an integer, which we can write as a fraction as 5 over 1. Then we have the cube root of 9. 9 is not a perfect cube, so we can't write this as a fraction. So not possible. And the reason is that 9 is not a perfect cube. Then in C we have the square root of 44. It's not possible to write this as a fraction. Since 44 is not a perfect square. Then we have the cube root of 64. This is equal to 4 because 4 cubed gives us 64. And we can write it as a fraction as 4 over 1. Both 9 and 16 are perfect squares. So the square root of 9 is 3. And that of 16, of course, is 4. Here we have the cube root of 0,1 to 5. We can first write it as a fraction as 125 over 1,000. And the cube root of 125 is 5, because 5 cubed gives us 125, and that of 1,000 is 10, and we can simplify this to a half. Then we have the fourth root of 16, which is equal to 2, because 2 to the power 4 gives us 16. This is an integer, and we can write it as a fraction as 2 over 1.